Hello friends, welcome back to the tetrahedron chemistry classes. So guys, from today onwards I am going to discuss a lecture series on the polymer science, and this is my first lecture, and the title of this first lecture is the introduction to the polymers. In this particular lecture I will discuss the uses of the polymers, and then we will see the different types of the terminology which is generally used in the polymer science. Okay, and then we will see the types of the polymerization and the mechanism of those polymerization. Let's see how much portion I can cover today. So this is your first slide, and you can see here in this particular slide I have shown you the sum of the uses of the polymers. These uses of the polymers are unlimited, but we cannot cover, or I cannot show you all the uses in this particular one slide, but I have summarized the uses of the polymers up to the maximum extent, right? So you can see here, this in the center you can see this is the polymer, and then you can collect this polymer to what? Medicines, right? So these polymers are of immense importance when it comes to the medicine, or you say the medical science. So first of all, the drug delivery. So it is not very important for you to know where these polymers are used in the drug delivery, but I can give you one example. The different kinds of the capsules, right, which we generally use. The outer coating of the capsule generally are made up of the polymers. So this is just one example, right? Similarly, these polymers are also used in the surgery. Basically, the biodegradable polymers, they are readily used in the stitches. When you have, when some person met some accident and that person sustained some kind of the injuries, then in surgery also these polymers are of very, very importance. In oral medicines also, you can see I have given you the example of the capsule, right? So there are enormous numbers of the uses of the polymers in the medicines also, but you can remember in drug delivery, surgery, and in the oral medicines. Then if you go to the electronics, right, if you are an engineering student, right, and you are doing your electronics, then you should know the polymers, where these polymers are used in the electronics. So transistors generally, which you actually observe, which you see in your basic electronics, these transistors generally are made up of the polymers. Different kinds of the sensors, they are also made up of from the polymers, and plastic diodes are very common. Again, these are the very few examples, but these examples are not that much only. These are unlimited. Okay, and then you can go for the environmental protection. This is something very, very important, because in the current world people are much worried or much concerned about the environment, because we are directly connected to the environment, and whatever bad thing happens to the environment, it comes back to us, right? That's why we are very interested to protect our environment. Okay, so in environment protection also polymers play the very, very important role. Say for example, low energy cement. This energy is very, very important, and one very basic fundamental is that when energy is very high, then the stability of the system is very, very low. Both actually energy and stability are reciprocal. Generally, if you have the Portland cement, right? Portland cement, I am assuming that you know about the Portland cement. This Portland cement, or the cement industry, actually produces cement which actually demands very high energy. But we can also prepare a cement like aluminosilicate cement, right? This aluminosilicate cement, the formation or the manufacturing of this aluminosilicate cement requires very low energy, and when energy is low, that means you are spending low amount of the energy or the fuel to this particular system, and in turn you are also emitting very limited amount of the poisonous gases in the environment. But in the high energy processes, you actually impart, or you give the very high amount of the energy and very large number of the pollutants to the environment. In the manufacturing of the low energy cement, this aluminosilicate, it is very, very important, and this is one aspect of the environmental protection. Similarly, fireproof components we made, these are again reduces the energy, and in turns they play the very important role in controlling the global warming also. Similarly, if someone is working in the mines or the nuclear hazards, then we can use the various material which can encapsulate hazardous waste in the mines or in the nuclear power stations, and in these operations also polymers are of immense importance. You should know this thing, right? And then when it comes to the daily life, right? See, daily life means, see, if you are early in the morning and you slip in your feet into the slippers, then those slippers are generally made up of your polymers, right? If you comb your hair, then all these combs are also made up of polymer, especially nylons are used. Then brushes or your toothbrush bristles, they all are made up of the polymer. Similarly, plastic chairs are also there. So in daily life also immense uses of these polymers are there. Similarly, if you go for the sports, right, say then your football, it is made up of the polymer. Helmets which you use in the cricket or in the rugby or in the various, say in the cycling, various sports, all these things are made up of the helmets, right? Similarly, your glasses, generally your polycarbonates are used in the manufacturing of the glasses or the sunglasses, or you can see the safety glasses basically. Apart from this, you can see the rubber is another example which is very frequently used in the automobiles, in the manufacturing of the tires and various things. So this slide is just an example where we can use the polymers. I hope this much of introduction to the uses of the polymers is enough for you, right? Now moving to the next slide, you can see here the classification of the polymers. It is something very, very important, and you should know how we can classify these polymers. So here you can see the slide. First of all, this classification is based on the origin. Origin means from where we are getting the polymers. So first is the natural polymer, and after natural polymer you are having the semi-synthetic polymer, and then you are having the synthetic polymers. Natural polymers are those polymers which generally we found in the nature. There are various examples of natural polymers like DNA, deoxynucleic acid, right? And your RNA, ribonucleic acid, the DNA, RNA, right? They all are natural polymers. Similarly, your starch, your cellulose or wool, whatever we are using in our daily life also, right? Generally, in winters we need the sweaters, and these sweaters are made up of the cotton, right? And they are made up of the wool. They all are natural polymers. And then there comes the semi-synthetic polymers. Semi-synthetic polymers are nothing but we actually enhance the sum of the properties of the natural polymers by the addition of the certain groups, right? So these are the semi-synthetic polymers, and some of the examples are what? You can see the nitroacetate and nitrocellulose. These two are the very fine examples of the semi-synthetic. And after that there come the synthetic polymers. Almost 90% polymers are the synthetic polymers. Please remember this thing. So your PVC, where PVC means your polyvinyl chloride, right? It is your synthetic polymer, like PP, polypropylene, PMMA, polymethyl methacrylate, PET, polyethylene terephthalate. They all are synthetic polymers. So this classification, right, natural, semi-synthetic and synthetic, this is based on the origin of the polymer. Then there comes the second kind of the classification based on the chemical structure, right? So chemical structure means homopolymers and copolymers. See, in the upcoming classes I will explain the difference between the homopolymer and the copolymers in the pretty much detail, right? Generally, homopolymers are those polymers whose backbone are made up of only one type of atom, right? Generally carbon or silicon, you may say. But when you have the copolymer, right, in copolymers, in the backbone of the polymer chain, you can find more than one kind of the atoms. But in the upcoming classes, I'll throw a detailed light on this particular classification. But up to now, it is very important to note that the homopolymers contains only one kind of the atoms in the backbone, and copolymers may have the more than one kind of the atoms, right? So examples of the homopolymers is the PE, polythene, right? If you synthesize the polythene, so the synthesis of polythene is what? You take this ethylene, CH2, and take the large number of these and subject it to this into the polymerization, then you will have the polymer, right? This polymer is generally known as the polythene. Okay, this is your polythene. So this is having only carbon atom in the backbone, so it is the homopolymer, right? And then there comes the copolymer. Copolymers means more than one kind of the atoms present in the backbone of the polymer, right? See your nylon. Nylon basically nylon is a copolymer which is having the carbon and the nitrogen in the backbone. I'll discuss this thing in the pretty much detail in the upcoming lectures. Similarly, you have Buna S rubber, butadiene styrene rubber. It is also having the more than one kind of the atoms present in the backbone of the polymer. That's why it is the copolymer, right? Up to now it is important to know that, but we will discuss the detailed classification in the upcoming lectures. And after that you are having the third classification, which is based on the polymer structure. So based on the polymer structure, your polymer may be linear, it may be branched, it may be cross-linked. So when you say it is the linear polymer, so only linear chains are there of the polymers. Okay, and when you say the branched polymer, so in the branched polymers you may have the branches in the polymer chains, right? Then there come the short branches, long branches, star branches. Lots of other classifications are also there, but you need to know only this much of thing, linear and the branch. And after that you are having the cross-linked polymer. That means there would be the cross-linking between the polymer chains. So this is one polymer chain, this is another polymer chain, and they have the cross-linking between them, right? Just like that. So these are the cross-linked polymer. So linear, branched and cross-linked, and there are some of the examples of the linear. See, polyethylene, polyvinyl chloride, polystyrene, polyamides, Teflon, they all are linear polymer. And your low density polythene, LDPE, low density polythene, and other polymers can also be modified to the branch polymer. But you should remember this low density polythene is your branched polymer like this. Please remember. And then the cross-link, your phenol formaldehyde resins basically, if you talk about. So bakelite is the very fine example of the cross-link polymers, and melamine is also another example of the cross-link polymers. And these cross-link polymers are of immense importance in the paint industry, where we manufacture the water repellent or weather coat type of the paint, where actually the cross-linking is there. So this classification based on the polymer structure. Then there comes the on the basis of the tacticity. See, tacticity is very, very important, and I have discussed this tacticity in the pretty much detail in one of my earlier lecture, which I have made only for this tacticity concept. So here you can see I am giving you the link in the description box also, and at the top right corner the link is also flashing for the tacticity. You can click on this particular link after the completion of this lecture, and you can find the link in the description box also. And by going through this link you will know the detailed things about the tacticity. But for now it is important to note that on the basis of the tacticity we are having the three kinds of the polymers, right? First is your isotactic polymer, second is the syndiotactic polymer, and third is the atactic polymer. Basically tacticity is the stereochemistry of the polymer, but right now I am not discussing that thing. I am giving you the link in the description box, you can go there. Okay, so example of the isotactic polymer is the PP. PP is the polypropylene. This is isotactic polymer. And your gatta parcha, kind of a rubber, right? It is your syndiotactic polymer. And your polystyrene and PAN. PAN is polyacrylonitrile. This is your atactic polymer, right? So these are the examples of the isotactic, syndiotactic and atactic polymers, and the details of this I have already explained in my earlier lecture, right? And then after that there comes the based on the, you can see here, based on physical state, right? So another classification based on the physical state was amorphous polymers and the semi-crystalline polymers. Crystalline polymers are not there. Okay, so amorphous, the examples of the, see, you know the different stages, liquid, solid, liquid, gas, and the different kind of the crystals, right? Perfect crystals, amorphous, powder like, and semi crystals. I am assuming that you are aware about these things. But see, whenever you are having the amorphous type of the polymer, then the best example is for amorphous polymer is what? Your polymethyl methacrylate, polystyrene, polyvinyl chloride. And after that, the semi-crystalline polymers, PE, polyethylene, PET, polyethylene terephthalate, PP, polypropylene. See, it is very important to know at least one or two examples of different types of the polymers based on the classification. It is very important. So let's move to the next slide. Now I am going to discuss the based on the thermal behavior, classification based on the thermal behavior. So based on the thermal behavior, there are two kinds of the polymers. First is the thermoplastic and second is the thermosetting plastic. So thermoplastics are those plastics which actually liquefies on the melting and then solidify on the heating. And the importance of this thermoplastic is that we can mold or we can design the articles in any shape by the application of the temperature. And the example of the, see, in the upcoming lecture I will also discuss the detailed behavior of the thermoplastic and the thermosetting plastic, but right now I am only discussing the classification. Okay, so here you see thermoplastics. The examples of thermoplastic is the polythene, nitrocellulose and nitroacetate. And then there comes the thermosetting plastics. Thermosetting plastic are those plastics when you apply the temperature on the thermosetting plastics, they actually take a particular kind of the shape or the particular kind of the design, and that particular shape or the design cannot be remolded again and again. Generally they set on the application of the temperature. That's why it is known as the thermosetting plastics. And the very common example of the thermosetting plastic is the Teflon and other resins. Resins means phenol formaldehyde resins, bakelite and many more, right? I'll discuss these things in the upcoming lectures also. And then after that, another classification is based on the conductivity. So basically we are having the conducting polymers, we are having the non-conducting polymers. Okay, so these two kinds of the two different classes based on the conductivity is there. First is the conducting polymers. Conducting polymers are those polymers which can conduct electricity. The conducting polymers are readily used in the electronic devices, right? And there are many examples of the conducting polymers, right? But you can remember this polyaniline, and you can also remember the polythiophene, right? In the upcoming lectures, I will also discuss the detailed structure of these polyaniline and polythiophene also. And more than 90% polymers are your insulators. That means they cannot conduct the electricity, or so most polymers generally are insulators. Polythene, PVC, they all are your insulators. And after that, based on the environment, so eco-friendly polymers and non-eco-friendly polymers. So basically more than 90% polymers are non-eco-friendly, and very little, somewhere around 2 to 5% is actually eco-friendly, 95%, then 90 to 95% is non-eco-friendly. So all the biodegradable polymers, they are the eco-friendly. Like say you are having the starch, right, and you are having the cellulose. These generally degraded by the biological action. So they cannot, so they do not cause any kind of the harm to the environment. That's why they are eco-friendly. But rest all, whether you are plastics, whether you are fibers, right, and many other things like polyvinyl chloride, right, and polythene, they all are actually the non-eco-friendly. They have the adverse effect on the environment. And after that, this based on the polymerization, this is something very, very important. Classification based on the polymerization, and based on the polymerization there are basically two kinds of the polymers. First is your say addition polymers, or addition polymers are also known as the chain growth polymers. Okay, and the examples of the addition polymers are basically your vinyl glasses like polythene, polypropylene, PVC, pen. They all are the addition polymers. Okay, and addition polymers are those polymers which are formed by the addition of the monomeric unit. There are no byproducts in this polymer reaction, right? And then there comes the condensation polymers. Condensation polymers are also known as the step growth polymers, and the examples are nylon, epoxy resins, polysulfones. There are many other examples are also there, and in the upcoming lectures I will discuss the detailed mechanism of the condensation polymerization as well as the addition polymerization. And lastly, the ultimate form, the ultimate form, that means the end product which we will use of these polymers. This is something very, very important. Say plastics, right? And then the elastomers and then the fibers. So I'll make or I'll cover the detailed lecture on the plastics and then the elastomers and then the fibers. So I hope this classification, or rather you can say that these detailed classifications of polymers, I hope you understood pretty well. Okay, but the important thing is that you should know the example of each and every class of the polymer, whether it is based on the origin, based on the environmental, based on the chemical structure, polymeric structure, tacticity, thermal behavior, conductivity, right, or many other things. You should know at least one or two examples each of them. Okay, so there are various examples, and the next thing is the important terminology used in the polymer science. So first is you can say here the monomer. So what is the monomer? These monomers are the small molecules with two or more binding sites or the reactive sites through which it can form covalent bond with other monomer to form a polymer. This is something very, very important. See, whatever the small molecule you are using, for example, I am using this CH2 double bond CH2. This is a monomer, and that monomer can produce on polymerization polythene, right? And here you can see this double bond is there, and when you break this double bond homolytically, then it will give you what? CH2, single bond CH2, and dot is here, dot is here. These two dots are the single electrons. So this is one reactive side and this is another reactive side. And it is very, very important for a molecule to act as a monomer. It must have at least the functionality of two. It must be the bifunctional. That means two functional groups or the two reactive sites must be there in a small molecule in order to act as a monomer, right? More than two binding sites or the reactive sites are also there in the monomer, but it must be bifunctional in order to act as the monomer, right? And then after that, after monomer, you are having the polymer. This is your next is the polymer. Polymer is what? It is the macromolecule or the large molecule formed by the repetition of the repeating units. So I'll discuss in a little while what are the repeating units, right? So whenever you are having a particular kind of the repeating units, and these repeating units are repeated n times, generally 10 raised to power 3 to 10 raised to power 7 times to produce a polymer, and this gives you the molecule. This gives you the molecular weight or high molecular weight of the polymer. Here you can see I have written here molar mass of the polymer vary from 10 raised to power 3 to 10 raised to power 7. So that means this is the molar mass. See, later on I will also discuss the numerical based on the molar mass of the polymers, right? And next important term, which is very, very important, the degree of the polymerization. And generally in the abbreviation of the degree of polymerization is the dP, or sometimes it is also written as xn. So whether you write dP or you write xn, they both are the same thing, please remember. So what is degree of polymerization? So I have written the definition here. Number of the monomeric units or the structural units present in the polymer, right? Say you have synthesized a particular polymer, so what you can do, you can count the monomeric units, which are also known as the structural units. So that particular number of the monomeric unit is basically the degree of the polymerization, and degree of polymerization is calculated as the ratio of the molecular weight of a polymer, right, and the molecular weight of the structural unit. This thing is very, very important, you should know, right? Sometimes in various textbooks you can find this term molecular weight of the repeating unit. Please remember, degree of polymerization is not the ratio of the polymer to the repeating unit, but it is the ratio of the molecular weight to the structural unit. It is not the repeating unit. There is the difference between the repeating unit and the structural unit, and in a little while I am going to discuss the difference between them also. So what is a structural unit basically? A structural unit basically is it is a substructure derived from the monomers. So what is the repeating unit? Please see carefully. Repeating unit, that is repeated throughout the polymer structure, composed of the minimum number of the structural unit necessary to generate the polymer. That means if you want to synthesize a polymer, so for the synthesis of the polymer, there is a requirement where we need the minimum number of the structural units. And when these minimum number of structural units are there, and these structural units basically forms a repeating unit. They forms the repeating unit, and this repeating unit when continues, it gives you the polymer. Please remember this thing. So you can read this definition again and analyze this definition by your own. The unit which is repeated throughout the polymer structure, and that repeating unit is composed of the number of the structural units, and that structural units may composed of the more than one monomer or the one monomer, and they are necessary to generate the polymer. It is something very, very important which you should know generally, right? So later on we will discuss the examples also. Let's see. Then after that you can see there is another very important concept which is known as the functionality. Functionality means the functional groups present in the molecules on the reactive side. Basically functionality is what? Number of the bonding sites or the reactive site present in the monomer. In order to act as a monomer, the molecule must be at least bifunctional, which I have already told you, right? You can see here this is your acetic acid, right? This is your acetic acid, and the formula of acetic acid is this. It is having only one functional group, which is COOH, and no other functional group is present. That means its functionality is 1, and when the functionality is 1, you cannot synthesize any polymer of this. That's why acetic acid cannot form any kind of the polymer, because it is having the functionality of 1. But if it is having the function, say if your acetic acid having the functionality more than 1, then of course it will form the polymer. But we know it is having the only one acidic group, so its functionality is 1, it cannot form any polymer. After that you can see the malonic acid. Your malonic acid is having the two acids group, right? Then functionality is 2, it can produce the polymer. Similarly your ethyl alcohol, you can see this is the example of your ethyl alcohol, C2H5OH, and only one functional group is there, it cannot produce polymer. After that ethylene glycol, it can produce polymer. Lactic acid, it can produce polymer, right? And then after that your tartaric acid, it is having the functionality of 4, it can produce the polymer, right? Vinyl chloride, it is having two functional group, one is what? Double bond, and second is what? Cl, right? Or if you break this, right, if you are not counting this Cl as the functionality, so this double bond itself act as the polymer, right? Similarly acetylene is having the two binding sites, so it is having the triple bond, so its functionality is also 4. So whenever you have the functionality more than 1, only then you can produce the polymer. Otherwise it is not possible to produce a polymer of such kind of the molecule which have the functionality of the 1. And see the difference between the structural unit and the repeating unit. This slide is of particular importance, immense importance, right? So what you can see here, this is the repeating unit. This is the repeating unit of your PET. PET is what? Polyethylene terephthalate. It is a kind of the polymer which is used in the manufacturing of the packaging bottles basically. See water bottles, right? Your drinking water, they comes in this PET jar. Okay, and this is the repeating unit where you are having the oxygen, 2 of this, and then your ester functionality, and then extra function. This is the repeating unit, right? Repeat unit of what? PET. And here you can see this is your polyethylene. This is the repeating unit of your polyethylene, right? If you have the polythene, so this is your repeating unit where you are having the carbon, single bond carbon, and the 2 bonds here and there. And what is the structural unit? See, this is the repeating unit and this is the structural unit, right? That means this only part is repeating several times to generate a polymer, and this is also forming the structural unit, and you know the minimum number of the structural units are required in order to synthesize a particular polymer. I hope this is quite clear now what is the difference between the repeating unit and the structural unit. Similarly, you can see here this is the repeat unit, right, of polyethylene terephthalate. How we can synthesize or how we can make this repeating unit? This repeating unit is basically made by the combination of, or not combination, made by the reaction between the ethylene glycol and your terephthalic acetic acid, right? So here two structural units of PET, that means structural units are the monomers present in the polymer. So this is one monomer glycol, this is another monomer, it's a terephthalic acid. These two are the structural unit. Basically the monomers present in the polymer, monomers used in the synthesis of the polymer is known as the structural unit, right? And this is the repeating unit, which is formed by the combination of these two. Please remember. Similarly, you can see this part is repeating again and again, but in the polythene structure, if you check here, polythene structure is like that. This is actually your structural unit, right? So this is something very, very important which you should know. I hope this is clear now. The number of the monomers basically are the two structural units, and repeating unit we can form by the combination of these two, right? But in case of the polymers which have only the functionality of two, it is quite easy, like we have seen in case of the ethylene, right? So I hope this is quite well understood now. And then the types of the polymerization. There comes the types of the polymerization. So basically there are two types of the polymerization. Basically in general actually the addition or the condensation polymerization, but after that the coordination polymerization is also there. But we will see the addition and the your condensation polymerization in pretty much detail. Okay, so I'll continue this types of the polymerization in the next lecture. Okay, I hope you understood the classification, terminology and the uses of the polymers in this particular lecture quite well. In the next lecture, maybe tomorrow, I'll upload the this part actually, which is your types of the polymerization. I hope you enjoy the lecture. If you like the lecture, please subscribe the tetrahedron chemistry classes and do share with your friends also. Okay, that's it for today. Thank you very much.